Great, thank you. Is this, you guys have turned me up? Or, I don't know, I'm pretty loud, so thanks for the intro. Just kind of do a couple things to kind of frame this discussion, right? So I'm gonna give a perspective of the work we've been doing with several hundred clients in the deployment of advanced analytics around Spark and AI applications in a wide range of enterprise use cases. I'll talk a bit about those use cases. And I was hoping to share some of those learnings and some of the things we've built around the environment and the tools we provided clients to help them be more successful in that deployment and those use cases. You know, typically, so we've packaged this up notionally as a infrastructure reference architecture for AI deployments. You'll see it on the website. There's some links and things like that. And our goal was to sort of take that at best experiences that we had and some recommendations, right, to make life easier for data scientists and IT professionals trying to build an AI infrastructure on-prem, right? And just to kind of triangulate where I live within IBM, which is always important to understand because it gives you a frame of reference of what we talk about, right? So I'm in the cognitive systems team, right? So the power server cognitive systems business. And I lead the product management or offering management team for Spectrum Computing. So my business is a software business. That business is really about distributed computing. Started in, I've been in this business for over 15 years. And our customers kind of run the range of large HPC simulation environments running our software to large high performance analytics environments running our software in risk management financial services to now Spark and AI workloads. So we've had a Spark offering for about 3 years called Spectrum Conductor, sometimes called with Spark, where we deliver an on-prem enterprise Spark infrastructure environment to allow clients to build multiple multi-tenant kind of high-performance Spark execution environment for Spark-based applications. And we've extended that, and I'll talk a bit about an offering we call PowerAI or PowerAI Enterprise, which kind of extends that and provides kind of a full platform for people wanting to do enterprise-grade deep learning and AI. So I'll talk about all those things. If you want to reach me afterwards, there's my email address. Surprisingly, out of the 450,000 people in IBM, I'm the only person with that last name. So I'm not sure why, but so let me get started, right? So a bit of an overview, right? Like I said, we've seen these challenges, right? And so one of the benefits of having a large organization like IBM and a large go-to-market emphasis around AI, deep learning, and these kinds of use cases is we have organizations that we interact with around the world, right? So we have a lot of experience across verticals and sectors within our team who've been building some of these products and offerings to engage with clients, right? And some of the references I'll make in this are public references. So this sort of conversation that we're talking about here, we have clients like Wells Fargo in the United States building their AI deep learning environment around this kind of software capability and this architecture. We have clients in the medical space like Washington University in St. Louis and Vanderbilt who did a whole bunch of work around MRI processing with deep learning. And that's, you can go to YouTube, Google it, and you'll see the guy talk about what he's done with the technology, right? So, so we've seen kind of different entry points for the AI and the deep learning space within our clients. But, and I always say, from a perspective, right, there's this balance between tactical and strategic, right? The creation and deployment of AI tends to be very tactical, right? You solve a business problem, you do a better job of predicting something. You predict a better outcome, you use deep learning or an AI model to predict an outcome, and you apply it to a business problem. The strategic is, there's probably 100, 200, and 1,000 of those opportunities within an enterprise. So the tactical is, where do I start? How do I get my first model deployed? How do I solve a problem? And the strategic then is, how do I scale that to tens, hundreds, thousands of users, hundreds of models, different types of models, different types of use cases, right? And so we've tried to sort of think this through across that whole gamut from POC experimentation to first production deployment to enterprise scale. So from a market space perspective, I think every technology company that talks about AI and advanced analytics probably has this industry chart in their deck, right? Some form of this, right? But I just kind of want to ground this conversation in real world, which is we've actually got engagements in every one of these cases with clients who are looking at how to make AI work for their business, right? So a couple of examples, right? Obviously, autonomous driving or ADAS type functionality in the automotive space is a big area for big models, big complexity, right? But we have, simpler situations where it's solar panel quality image detection. It's LCD panel defect prediction on the assembly line. It's steel quality prediction based upon the materials going into the steel production, right? So very simple tactical, not simple, but very tactical things that are part of a solution to a client business problem, but examples we've seen, right? I mentioned some of the life sciences one, right? So stock index future prediction example in this case, right? I don't know where security is, right? But a lot of customer analysis and marketing prediction across telecom and retail, large retailers, and those kinds of use cases we're seeing on this platform. And then one that, not obvious here, but we've done a case, a solution for ATM camera fraud detection. So customer comes to take money out of a bank machine, they're wearing some sort of mask, predict if that's a mask for a dust or environmental reasons, or if that's a mask because they're disguising their face to use somebody's stolen credit card. Right? So that's sort of a real world example of some of the cases we've seen. Right? So all of those kind of feed into this conversation, and generally all of them start with a single starting point application or a single tactical kind of use case, but we find our clients have somebody who has a vision of how they're going to build this platform. And our focus, interestingly enough, I know there's a lot of cloud focus, right, on this. Our focus has generally been with clients who have a lot of data that resides on premise, right? So a big data challenge, the data already exists or the data exists across the enterprise. So they're looking for some of this data science infrastructure and AI infrastructure to be deployed into their, inside their firewall on their premise. So as we engage with these clients, we end up with a conversation about the whole deep learning or AI pipeline. I'm not trying to teach everybody about this, but just kind of share some of the things we see, right? And we've sort of broken this down into sort of 5 big blocks of functionality, and then I'll talk a bit about particularly the data transformation, some of the data things that happen that we see being critical, right? So it starts always, right? People want to get this up and running quickly, right? And what we see, obviously, is the ecosystem around advanced analytics, in-memory analytics with Spark, and deep learning changes like every day, right? Well, some of it changed yesterday in a big way around the big data space, of course, right? But things like TensorFlow, PyTorch, Caffe, the frameworks, all this stuff iterates really quickly. And so we find clients who want to iterate really quickly with the frameworks, but they also then struggle with the enterprise support and production capabilities of getting something that they can use, that they can rely on, right? So, and get support for. So that's definitely an area of focus, right? The data prep, so as part of our solution set, as I mentioned earlier, we embed Spark, and we manage Spark and manage Spark on a multi-tenant basis on the same platform. So all the data prep, ingestion of data can be done through authored Spark applications that the clients can do themselves or we can help do for them, right? So that's part of this end-to-end capability. We also have some tools in the portfolio for auto ML capabilities, so in image tagging and object detection, object tagging and things like that. So I'm not going to talk a lot about that, but there's another set of capabilities that we offer there as well. The build, train, and optimize, that's really where the crunching happens from our perspective to start, right? And we've put together a set of capabilities and experiences with clients to help them get those models trained faster. That can be small models on single machines, or that can be a lot of different options for distributed training. The deploy and inference, initial deployment and inference kind of in testing or small scale, but then now starting to see people really thinking about how to scale large scale volumes of inference, right? And some things to support that, right? Both from parts of IBM are working on things on model assurance and quality. That's not so much my area of focus. My area of focus is scalable inference serving, right? Delivering elastic distributed inference capabilities. And then finally maintaining accuracy. And there's a whole sort of obviously iteration and workflow that happens as we look at this deep learning pipeline. And that deep learning pipeline on the data side tends to have lots of fictitious or example roles of people who are touching and manipulating the data as you go through this process, right? And our point of view is, and I think it's pretty common, right, is that this is going to be a team sport. You're going to have multiple different roles, data engineers, data scientists, IT people who need to be in the mix, right? And supporting kind of an environment or a platform that the organization can use across different lines of business or user groups to support this workload and these kinds of things is really critical. And part of that becomes the common data platform. And sort of part of the reference architecture conversation extends beyond here's some servers and here's some software to run on the servers. It also extends into some options for high performance storage and serving of the data so that you can ingest large volumes of data, say in the automotive use case, hundreds of petabytes a year, and then you can serve that to large scale training environments. So that data workflow then sort of builds across the phases, right? And starts obviously with ingest, right? There's lots of different kinds of sources of that ingested data. We know that's going to be years, maybe longer term sources of that data. That transformation process then happens where we cleanse and pre-process. We find, in this ingestion phase, a lot of work to start, even in this activity with clients, really starts with a set of Spark applications that they create to pull a lot of this data together and transform it for their use cases. And then we feed into a set of capabilities to build, train, and optimize, right? And again, tend to try and do that. The faster you can train or the faster you can fail on training, the faster you can get to a better output or a better model, right? And so days and weeks. And then finally in production, inference can happen on the deep learning side in multiple different ways: batch inference, real-time inference, all those kinds of capabilities, and requiring data to be fed in transactional format or large batches of, say, object or video images to be fed or streamed in for measurement or for inferencing. And then finally, that obviously becomes new data, and the cycle, rinse, repeat cycle continues, right? And we know, and I think everybody gets the sense, right, and our clients get the sense that doing the build, train once is never what's going to happen, right? That gets promoted in inference or production, and then this cycle kind of continues ad infinitum, right, as people work through the issues of getting more accurate models, new models, different models, more data comes in, you have this kind of continuous loop of ongoing training and execution. There's a lot of boxes in the middle here of, in the training and optimization. I'm going to dig deeper in some of these, right? I'm going to talk a bit about the transform phase, some of the things that we've seen be useful, and I'm going to talk a bit about the build, train, and optimize phase. A lot of our focus so far has been on this transform and build, train, optimize. Now starting to get into inference as people get their first models and looking for ways to deploy those and scale inside the enterprise. So we've packaged up this set of capabilities under a brand name, right, from our portfolio, right? And you'll see it branded as PowerAI. The portfolio for the kind of the enterprise platform is PowerAI Enterprise, surprise, surprise. But it also supports both mixed x86 and Power environments, right? So some of the capabilities are really optimized to run on Power because there's some different Power server capabilities. But in general, we support, and specifically we support blended x86 or x86 only environments as well with the software. And our goal, right, in this portfolio is sort of, as we've engaged with these hundreds of clients, as we've understood kind of some of the pain points and trying to resolve some of these things and put them into a package that we can deliver, right, we've kind of put together a set of capabilities, right? So one of the things you can do with PowerAI is we've got a distribution of the frameworks. You can go grab that off the IBM website. It's free to use, free to download, right? So you get some base frameworks with some optimizations, right? Then we've also got this ability to deploy this enterprise platform quickly. We've extended it in multiple dimensions for ease of use or unique capabilities. We embed hyperparameter search and optimization. We embed and have the capability for elastic distributed training, which I'll talk a little bit more about. We have some of this data pre-processing capability. And then we also can leverage the distributed training and the data bandwidth capabilities to increase or reduce the model training time, so get models faster. And then from an ecosystem perspective, we see this pretty open, right? We partner with Anaconda, partner within IBM, so some of our Watson products integrate with this, Watson Studio as an example, or external partners like H2O AI, right? So a range of things, right? And obviously from a Spark perspective, leveraging foundational Spark and some potential beyond that. So that kind of gives you a view of the sort of the packaging or sort of the vision of kind of what we're trying to deliver for this enterprise AI platform. So some quick screenshots, right? So on the data preparation side, we got a workflow capability that allows you to load in the different data sets, fit to the model formats, right? TensorFlow or Caffe or PyTorch, and supporting a wide range of frameworks on the environment. Split up the data for training and testing purposes. Have opportunities when you do that data prep to visualize the data, preview results. We run a set of transformation jobs in Spark to actually prepare and look at all the data. In this case, it's a bunch of thumbnail images on, I think those are like MRI scans. On the optimization of the training side, one of the things we found to be really useful, right, is providing a set of base capabilities on hyperparameter search and tuning. So as data scientists go to build their models, we've included the capability to search the hyperparameter space in multiple different ways and provide recommended starting points for the training run. So this is all built in to the PowerAI capability. We call it Deep Learning Insight as the sort of the feature name or the capability name. And it sits on top of the GPU servers. And we basically spawn off a whole bunch of short sort of test jobs to try and search for the right starting point for the training. Again, the goal is to get convergence and a better accurate model faster. So once that training is running, a bunch of visualization that works across TensorFlow, Caffe, PyTorch, so you can visualize what's happening on that particular run. And then also have some code in there and some capabilities in there to push the optimize button and make some recommendations on changes based upon what we're seeing on that particular training run. So again, all these tools kind of coming together to try and help with the process of visualizing and running the training and monitoring and analyzing and optimizing and just getting to a model faster for the data science community. So one of the other areas that we've seen have a lot of potential and seems to resonate with a lot of clients is obviously the ability to then accelerate this training across the enterprise by distributing across multiple GPUs. And so we see multiple paths on this. And so obviously the one that I think most people would be familiar with is using sort of the distributed TensorFlow or Horovod or some capability, right, where the community has put together capabilities for distribution of the training across multiple nodes or GPUs. So we've also done some innovation in the portfolio for something we call the distributed deep learning library, which allows you to accelerate or single sort of job, single user, high performance training in parallel, right? So we've tested this on up to 1,000 GPUs or more, right? We've got clients, I think, running 4,000 GPU tests with this capability now. So the goal is, right, if you have a very large, complex problem, throw on more GPUs at the problem. In theory, should, with relatively linear scaling, should get you faster results. And the last area we've spent a lot of time on is trying to innovate around the options for elastic distributed training. So one of the cases we see in a shared environment with our clients is multiple users all submitting training at the same time. Some organizations also wanting to run inference on the same sets of GPUs at the same time and trying to manage the relative priority of how all that's going to execute effectively. And realistically, I always say, no matter how much capacity you think you have, you always will hit a capacity boundary. Your capacity boundary could be if you have a physical set of infrastructure on-prem, or your capacity boundary could be the budget you're willing to spend on your cloud provider, right? So eventually something hits the wall. And so one of the things we've done is have a set of capabilities to transparently extend frameworks like TensorFlow or PyTorch for dynamic addition and subtraction of multiple GPUs. So we give you the capability to elastically scale up and scale down the training run while it's in progress, and take advantage of more GPU power or shrinking your GPU access because something else needs more GPU capability on the infrastructure. So that kind of visual kind of tries to explain it, right? In this case, it's 2 servers, 8 GPUs, pretty simple, small case, right? T0, the first job starts, it gets all the GPUs. T1, job 2 starts with fair share. We'll split the GPUs between the 2 jobs, each get 4. As we change the priority of job 2, right, we give up more GPUs from job 1 dynamically over time. And then as job 1 finishes, we scale up to job 2 getting all the GPUs, right? So that's, one of the things we've really worked on this, and you can go search it. It's called Elastic Distributed Training on our website around PowerAI and Spectrum Conductor, is we've been working a lot on the transparency feature of this. So you can take the objective, right, and the delivery, the current delivery of this is, say for PyTorch, is take a single node PyTorch program, add 2 lines of code, and we can dynamically distribute it across multiple GPUs using Elastic Distributed Training. So that's kind of some of the things that we see being really powerful as you get into more users, more workloads, and more scenarios. In addition to some of the distribution capabilities, we've also created some capabilities around large model support. So in this case, there's extensions that we've created that allow you to take larger and larger models that may not fit on the individual GPUs or fit in the memory space of the GPUs on the box, and take advantage of, through NVLink to the processor, leverage the main memory of the CPUs as well. So we can put bigger and bigger models on a single box. So again, giving you lots of flexibility, or clients flexibility, to distribute this training and these workloads and gain performance and value, and making hopefully lives easier in terms of being able to solve bigger problems with deep learning. Sort of a typical use case. So I'm going to wrap up here in the last couple slides. So typical use case we've seen in a large client, right, is this notion of getting to high performance data science as a service. And as I said, right, our focus has typically been clients who have, say, their data lake behind the firewall, have other data sources, want Kerberos access to that data, want secure access to all that data, have kind of security policies that limit where that data can flow, and really are looking for this AI analytics grid to be deployed in their infrastructure. And that grid kind of needs to support, at its core, Spark for all that data transformation and data management functions, and then support the execution of deep learning training, like I talked about, with some variables and some flexibility, and then support the notion of inference running at scale. And in this case, right, we've got, this is an example where a client did it on our Power 9 servers. We have examples of clients doing Spark environments like this at 20,000 cores on x86 today in production financial services, right? And the goal, right, is, we expect lots of different user experience interfaces, different notebook experiences, different tools, H2O, Watson Studio, all kind of be, preferred or used by different groups. And from our perspective, what we're trying to provide is that infrastructure platform and reference architecture that allows people to build this easily so it scales within their enterprise. A couple other things we've done specifically on Spark, I just mentioned here. So when we get to the report serving and the aggregation, we've extended Spark with something we call shared RDD. So in our implementation, one RDD can be shared across multiple users within the same context, right? So we don't have to keep reloading data for different users. So just kind of to close on the last couple things here, right? What I started off with was sort of a discussion about how we get engaged in these sort of tactical but strategic initiatives around AI and deep learning in the client's environment. So the tactical part is, okay, I want to experiment. Single node, 1 or 2 nodes, one problem, start training, start experimenting around the training, realize that I'm going to need more to get to a real solution. And then, once they get through that first sort of experimentation phase, is move into, a real production, right? So get that first group of data scientists or get that first group of models into a production environment, and then eventually scale into that vision of a shared data science service, right? And deliver that across, heterogeneous infrastructure, leveraging lots of different data sources and serving kind of that data preparation, transformation, model training and optimization, and inference phases of this life cycle. And really, when we get to kind of the product pitch kind of, picture, right, or where the product names start to appear on each of these things, right? Basically what we've sort of put together around this architecture is built around kind of a range of our server platforms, the AI enterprise software stack running on Linux, running on Power and x86, supported by our high performance storage, file and object storage capabilities in Spectrum Scale and Elastic Storage Server for large data ingest and serving the training and inference phases, and then kind of growing the client's environment and infrastructure as they go from experimentation, stabilization to expansion. So one last picture here on some customer experiences. I mentioned Wells, right? They've been talked about this kind of a journey with us at Think last year. We've continued to grow the kinds of tools and applications they're using. We've had multiple cases on the data side and the deep learning side in the automotive space around the large volumes of data being generated from videos for training of automated driving. We have multiple clients doing large Spark and AI deployments, starting with Spark, then adding machine learning on Spark, and then adding deep learning and AI capabilities. We're drinking our own champagne within IBM because our global chief data office has built some capabilities and some around this kind of architecture. And then the one that sort of crosses over as one of the larger scale ones is Coral, which is one of the national labs in the US. They've just gone live with a 4,000 node, 24,000 GPU environment, mixed between classical simulation workloads and now starting to deliver more and more combination of simulation and and AI type workloads. So that was a quick tour. Hopefully some of the experiences we've had kind of came through. I could have put the links in here, we can add them. Essentially there's some links. If you search on our reference architecture, you'll find that. We're happy to engage with clients, bring some of this experience. Generally, we find some sort of workshop around where to get started with AI, a discovery workshop with your teams or client teams to understand what problem you're trying to solve, and then we can either bring some of our data science expertise or partners into that conversation, and then get started on one or two nodes, and then kind of build towards this enterprise vision, right? And we see that as being critical if the promise of these AI ideas are going to be realized in sort of a broad way across the enterprise. So that is my last slide. So thanks, everybody. I think I finished in 29 minutes. Hopefully that's on time. I'm following the 1 minute there, so thank you. Uh-oh. Real questions?
Yeah, one at least. What's the strategy of IBM for Databricks implementations? Because we have some clouds implementations we heard here in this event, but I don't see anything from IBM. What's the strategy? From
our perspective, so I can't speak for whatever the IBM cloud might be doing with Databricks. I can speak from an on-prem perspective. We do have some interest in looking at how we can enhance Spark in our on-prem product and leverage some of the capabilities that Databricks has. So we'll see what happens on that. I can't answer any more than that. But that's a good question. So there's some interesting discussions, right? So as we've engaged with clients, there's some Spark enhancements and features that are interesting for some of our large clients, right? So there's some potential there to figure out how some of that might work in bringing into our kind of on-prem infrastructure. So
Thank you for your presentation. I had the same question about your email ID as well when I saw that, with a company like IBM. How did you manage that? But besides technology, in your experience, what are some of the people skill, cultural challenges are you seeing in AI? Because I think it very quickly boils down to what do you want to do, and it's not as simple as taking a company to the internet. These are different challenges.
Yeah, so a lot of the cases, right? So we have at least, our team, our core team has worked with at least 20, 30 kind of customer projects, right? Where it's that specifically I can remember, right? Where generally, if a client has an experienced data science team that says, look, I know I'm going to do it. I mean, I know the problem I need to solve with AI, or the first problem I want to solve. Then it's really a conversation about, okay, these tools and this architecture that we built can help you solve that problem faster, right? So that's an easier case for us, because the other harder case is where a client is kind of sniffing around saying, I'm hearing about this AI thing, and I want to get started, but I don't know where to start, right? So that involves basically bringing more data science and model building skills to the client problem, right? And helping them to get that first one done. So within our sort of extended organization, we have a group called the Data Science Elite Team, which will engage with POCs with clients. What we've done successfully is our IBM research team is vast and complicated and has a lot of skills and capabilities, but they have specialties, right? So we have people who have built expertise on retail prediction, telco, those kinds of things. And so what we're doing is bringing those people to some of those discovery meetings and having a conversation with the client and some of our experts about, where should you start with AI? What's the stack rank of what's the most important thing? But eventually, you're going to need skills, right? So either that's kind of rent or own kind of your own skills from a data science perspective. And we're seeing that we have to provide a lot of that for some of these early clients. For sure, right? We're looking for partners, right? So if there's ecosystem, we got our big GBS services organization, but if you've got organizations that want to help clients adopt AI, we're happy to engage and add them to our partner program. Great. Thanks, everybody. Thanks again.